Let us now see the architecture of Pic16F887. So with the previous knowledge of having known about the core features of Pic16F887 microcontroller, let us now see the architecture of Pic16F887. So basically the architecture of Pic16F887 consists of these features or these circuits. So the first thing which it has is it contains IO ports, and the number of IO ports that is present in Pic16F887 microcontroller is 5. So that is port A, port B, port C, port D and port E. So basically ports are nothing but they are semiconductors which is used for the communication between your microcontroller and say any input output device. Next, it has flash memory. Flash memory is about 8K into 14 bytes. So flash memory is nothing but the program memory where you will be storing the program in the microcontroller. Then it has 368 bytes RAM. So this is in terms of register files, normal general purpose registers as well as special purpose registers. And it has 256 bytes of data EEPROM. It has 13-bit program counter. So program counter is nothing but a special purpose register which stores the address of next memory location from where the code has to be fetched and executed. So this is of 13-bit wide, and it has 8-level deep stack. It has instruction register and decoder. It has ALU unit and status registers. Like all microcontrollers and all microprocessors should have ALU unit. And like previously discussed about the special features of having power up timer, oscillator startup timer, power on reset, watchdog timer. So all these circuitries will be present. So it has 3 timers. It has a A to D converter inbuilt and a comparator. So now this is the architecture as you all can see. So just now I said that it has 5 ports. So these are that 5 ports. Port A, port B, port C, port D and port E. So as said, you can see that port A, you can see the direction here. It is bidirectional. That means it can be used as both input and output. These are nothing but the pins available on the microcontroller. I see. So it is used for the transmission of data from your microcontroller and to say any input output device. So port A, port B, port C, port D. So all these 4 ports are of 8 bits wide. You can see RA0 to RH7. It is 8 bit, whereas port E is 4 bit wide. This is about the ports that you can see. Next, coming to, as said that it has flash memory, that is program memory. It has a program counter and 8-level deep stack. Then it is instruction register and instruction code and decode and control unit. Say we all know microprocessor will not understand other language. That means it understands only binary language. So whatever is the program stored here, it will be in terms of codes. So first thing, this code will be taken to instruction register and it will be given to the decode circuit to decode. Then once it is decoded, it will be executed. Next, we have this power up timer, oscillator startup timer, power on reset, watchdog timer and brownout reset. So these are the special circuitries that are available in Pic16F887. So you can see memory clear, VDD and VSS. These are the power supply given to these circuitries. And next, coming to ALU unit. So ALU unit is nothing but arithmetic and logic unit. So it performs arithmetic and logical operations. So this circuitry. So after arithmetic and logical operations are performed from this circuit, you have a status register which will give us the status of the instructions that have been executed. Say arithmetic instructions that are executed. Say for example, if you have executed any addition instruction, like after addition whether you have got carry or not, so you can see that status using status register. Next, as said, it has 3 timers and it has analog to digital converter. So analog to digital converter, here you can give analog input, that is you have 14 analog input pins that can be given into analog to digital converter. Then you have analog comparator, then as said data EEPROM. Next, this is a pin configuration or pin diagram of Pic16F887. So first let us see this pins. So you can see here, this is nothing but port A pins, RA0, RA1, RA2, RA3, RA4 and RA5. So this is port A. Along with that, this pins can be used for multi-purpose. Say pin number 2 can be used as RA0 pin as well as analog input, and it can be used for ULPWC. So this stands for ultra low power wake up. So all these features will be discussed later as a topic itself, so need not worry about that right now. And this pin number 13 and 14 is again for port A. Next, pin number 33 to 40 is for port B, and pin number 15 to 18 is lower byte port C, sorry. And again from 23 to 26 is for port C, 19, 20, 21, 22 for port D, 27 to 30 is again for port D, and 8, 9, 10 and pin number 1 is for port E. So you can see pin number 11, 12, 31, 32 is for ground and power supply.